Okay, function notation 101 coming to you live here. So, first question, why the heck do we have function notation? Why do we need to know this? Well, it just so has it that we begin to learn this, I believe, for the most part, in maybe Algebra 1, maybe some other schools are a little bit different, but why do we do this? Really, it has a lot to do with calculus, to be honest with you, and or it has a lot to do with if I ever want to have a bunch of equations and I want to be able to quickly identify which equation I want you to be working with, we use function notation. Function notation is really just a way of us to name a particular expression. So say, hey, use that expression. So instead of say, hey, use that expression, say, hey, use the G expression. Hey, use the F expression. Hey, use the C expression, the T expression. Whatever expression you want to use, that's the one that we will use it for. So the other part that it does for you is that it signifies, just so you know, that when I plug a number in, there's no way I can produce any other number but the number that I create, presuming that it's done correctly. So if you do the mathematics correctly and you plug that number in 1,000,000 times, 1,000,000 times, you are going to get the identical same answer. Because yes, there are expressions and equations that do exist in which you can plug one number in and it gives you a different answer multiple times. So function notation does two things. Separates a bunch of similarly looking types of equations so that you can talk about specific ones, and it also lets you know that one number plugged in will only ever produce one number as its output. That's what it is. That's why we have it. Mainly, a lot of this time you'll see it is when you get to calculus or trigonometry or pre-calculus, where you start working with several functions at one time. So, moving on to some examples. So, how the heck do we use it? Let's look at this actual notation. So, notation might look like such. You might have this thing where it has this F and this X, or it could have a G and the X. So what I mean by that is, if I'm talking here, you understand, is that you see I have this F with this parenthesis X, and the next time I've got this G parenthesis X, this H parenthesis X, or this J parenthesis X. I could change this X to something else, this X to something else, but if I change this X over here must also change. So these X are linked. They are linked to one another, okay? They are ironically the same exact thing, okay? This side is a placeholder. This side is the side we use for calculations. So you can think of function notation as this is the calculation side, and this is simply the placeholder side to remind myself at the end of the day what number I plugged in to get this thing. So let's set something up. So what I put is here, I put a bunch of them. So what I mean by this is, before I was talking about to separate a bunch of them, so notice I have f of x equals this mx plus b. Then I have this mx plus b down here. Well, if I had two problems that were, say, like, okay, for instance, that if I say that this one particular one here, okay, so I separate these out really quickly. Let's pretend that this had been f of x equals 3x plus 2. Right? And then I said to you, hey, this one is h of x equals 7x plus 5. What I want to note here is that both of these things are in mx plus b, but if I didn't have this f thing here with this x and this h thing here with this x, and let's pretend for a second I said, hey, y equals 3x plus 2, and then I said, hey to you, y equals 7x plus 5, right? And I just had that, and I just randomly said, hey, when x is 2, right, find y. Well, if I plug 2 into here versus 2 into here, I'm going to get different answers. So this is what I meant by separating it out. Which one do you want me to plug it into? This is why we have function notation, so I know which equation to plug the two into. If you want me to plug them into both of them, okay, y's are fine. But if I want to start differentiating what number I plug into which equation, then we use function notation to help us out. So, going back to that, okay, oopsie daisy. Okay, so going back to this, okay, so, all right, so we can go back to here just to get rid of this really quickly. Let's pretend we have function notation. What the heck does all of this mean? Okay, so some basic notation with this stuff here. I'm going to get rid of all of this so I can put some notes here for you. Okay, so here we go. We move that one up. So a couple things I want to note that you need to know is that x on this side is what we call a placeholder. Okay, and it is a placeholder representing the input. All right, and I'll talk about this in a little bit in a minute. And this side is that identical input, okay? So that is the actual input as well, except this side over here, we need to remember, okay, is our calculating side. So this side is what we use for calculations. I spelled that wrong, huh? Okay, so this side we use for calculations. All right, so the left-hand side is never done with calculations, ironically, okay? The right-hand side is what we use for our calculations. So what this means basically is that in every single problem, whatever I start out with like this, I am going to have something like this in the end. So, for instance, let's pretend I have an equation that says f of x equals 3x plus 4, right? What this means is that any number that I place in here, I am going to do the calculation with over here to get the answer. So what we need to remember is that this side will be left, and the answer will be in the end, and I'll do some examples on the other side for a second, but what we need to remember is that this is a placeholder, okay? We need to remember this is a placeholder, this is the calculating side. Doesn't matter if I change it, this is the input. Notice I have double x's here. Well, I need to input for this x and this x. Anywhere I would see an x, I would input in. So let's do some examples of this. So for instance, it says, let's use it. Write y equals 3x plus 2 in function notation. So you can name the function whatever you want. The letter you choose out in front. So if I want to use a g, I am now going to call this the g function. So what I do is I do parentheses with this x, okay? Now, give you some more name. This is read as, we always read this as g of x. Now, the reason we say that is because we say g function with the input of x, or 3, or 5, right? So I'm really kind of saying this is the g function, okay, just so you know, with, okay, input, and then of, okay, and then x, yes? So basically, this first part here, this function with input is kind of like implied. We just shorthand script it, we get rid of it, and we just say, hey, g of x, because we're implying that this function with an input of x, that's why we just simply say g of x, if that makes sense. I hope it does. So let me get rid of that off of our screen very quickly so that we don't have it. So there we go. So basically put this in the function notation. If your teacher wants you to use an f, whatever it is. But either way, commonly you will see f's, but I'm going to use a g just to be a little different here. So I'm going to say g of x equals 3x plus 2. So in function notation, what you need to note is that this y is essentially going bye-bye, okay? And I am putting g of x instead. So again, I read this as g of x, okay? So down below, okay, I have some questions, so I'm actually going to use an F in this case, so I take that back. I'm not going to use a G, I do apologize, just so I have this, so here we go. I'm going to use F, so I'm going to say f of x equals 3x plus 2. So same thing that holds note, so the f function with the input of x is equivalent to this expression over here. So remember, this side is the calculator, this side is the placeholder. So let's talk about some examples of how your teacher might use this below. So if you notice, it says f parentheses 7. So what this is saying to you is use, so I want to go to the f function, okay, with an input of 7. Now that I'm plugging a number in, I can throw this word is on the end, okay? ... All right? So this is what I'm thinking of myself. So this is how we write it. We go f of 7, okay? And I write the calculation side, so 3, and now instead of an x, I'm simply doing, instead of an input of an x, I'm using an input of 7. So I'm simply saying to you, 3 times 7 plus 2 has an answer of what? So we write it as f of 7, so 3 times 7 is 21, okay, plus 2 is 23. So, again, this part here, if the number is replaced on the inside, we are asking you on the calculating side here, throw a 7 in and tell me what the answer is. So the f function with an input of 7 is. So that's how you can think of this question. The number 3 over here. So it says, when is f of x equal to 44? Now, what this is asking is what number, okay, so now this is asking what input, okay, gives me an answer of 44. So now I'm asking you, hey, I have this calculating thing of 3x plus 2. I need to plug a number in. But when I plug a number in, I need to make sure that it's going to equal 44. So what we do in this case is we make a little equation. And the little equation is we say, hey, this little thing right here, after I'm done calculating it, it better give me that. So we can make a little equation, just say, hey, equals 44. And that's all we do. And then from here, I can now solve. So I go ahead and I use my properties of equality. So my first property of equality I'm going to use is subtraction. So minus 2. Minus 2 from both sides. And I'm now left with 3x equals 42. My last step is to divide by 3. Divide by 3. And now what I'm left with is that the answer is x equals 14. So what this now means that if I were to plug a 14 into my equation, so 3 times 14 plus 2, I will get an answer that is 44. So what we were simply finding here on this time is what is the input that I can plug in to give me 44. All right, on to another example. Another example you might face is just a simple graph. Now, a graph, the way a graph is done, is that the graph, the input we need to remember is x, the output is our y, but more properly you'll probably see, instead of y up here, you will now see it as f of x, like such. Okay, so f of 3. So the answer to f of 3 is asking you, okay, for this f function, this little squiggly line that I've got drawing, okay, if I go to an x value of 3, so if I go to a coordinate pair that has an x value of 3, what will its partner be? So what I can do is I can go here and I can go, okay, let's go to 3. So 1, 2, 3. There it is. And now I'm looking for anywhere that I can go to this line. So if I go to this line, you look at this point right here. After I find that point, if I want to find its partner, I go over to this axis. So 3, go up. I go 1, 2, 3. And what I have, okay, is that this point right here. Well, this point has a value of 1, 2, 3. So the partner to f of 3 is going to be 3. So my final answer to this one is f of 3 is equivalent to 3. And what you note here is that in coordinate pair, if I put a comma between that really quickly, I get the coordinate pair 3, 3. So now we do it again, f of negative 6. So again, we follow this. So I just want to go to where my x coordinate is negative 6. So I follow my x-axis. Starting here, go to negative 6. 1, 2, 3, 4, 5, 6. So there's negative 6. And I'm going to go to anywhere I can find a point on this curvature line. So I go down 1, hey, 2, there it is. And the answer is negative 2. So at negative 6, I go down 1, 2, and I am on the line. So my answer to this one is going to be f of negative 6 will give me an answer of negative 2. So there's no calculations when I have the graph. It's just literally interpreting a graph. Because again, I'm trying to figure out negative 6 comma what will give me a point that lands me on this actual line, and there it is, negative 6, negative 2. Now, the second one, or the last one, sorry, the third one is a little bit more, it's a little different, okay? So now this time, I'm wondering where can I get a coordinate pair that has the second value as a 2? So now I'm going a little bit different. So instead of starting at the axis, at the origin here and going left or right looking for an x, I'm going to go up to 2. And then when I go up to 2, I've now to go to every spot, okay, not just one of them, that will give me an answer of 2. The first time I'm going this way, and I find that, the outcome is 2 when I plug in 5. So what I have for my first one is 5, 2, okay? The next time I do this, okay, so I go back to this again, All right, back to it again. And I go up to 2, and now I can go left, and I find, oh, wait, what is that? I go down, and it's 1, 2, 3, so it's negative 3. So now I'm finding I have multiples sometimes. So negative 3, comma 2. Okay, so if I had plugged the 5 in, my answer would be 2. If I knew what this equation was, as in forms of a expression or an equation, I could plug negative 3 in and also get 2. However, for this one, okay, you'll also note that if I go up to 2, I can go past that negative 3 and go all the way out here, okay, to negative 9, and it's about halfway, so I'm going to estimate that it is approximately at negative 9.5. I'm also going to get 2 again. So, I don't know that your teacher will necessarily give you one that has multiple outcomes like this, but they very well could. What you need to know is you're simply just going to find, you're playing the matching game. You turn a card over, if you played this as a kid, you turn a card over, you're trying to find the other card that matches it. So in a graph, I'm basically giving you part of it. You need to go find the coordinate pair that on the graph that will match me having something with the number that I'm giving you. If I give you the number, if the number inside the parentheses is giving, you got to find the x that matches with some y, or you got to find the y that matches with the x I give you. And if I give you this number over here, so if I give you the number on the other side, you need to go find the x, okay? So in this case, we went and found all the x's that gave you those 2's. All right, so I hope that helps. So one last example here to end our Introduction to Functions 101. And here we go. We're going to end with another equation. So this one is simply going to be asking, hey, f of 12. So this f function up here, okay, if I plug a 12 in, what do I get for an answer? So remember, this side is the placeholder. The right-hand side is the calculation side. So I now am going to go 2/3 times 12 minus 5. The first row, you should note that the 12 and the 12 should match identically. Thereafter, the left-hand side stays a placeholder, so f of 12, okay, stays there as a placeholder. The right-hand side becomes a calculation. 2/3 of 12 is going to be 8, so 8 minus 5, okay, is 3. So f of 12 is equivalent to 3. Continuing on. F of negative 6 is equivalent to, again, 2/3 times negative 6 minus 5. Again, the first row, you should note that these two things are going to match. Thereafter, this side is the placeholder, so f of negative 6 equals, this side is going to be the calculating side. So 2/3 of negative 6 is negative 4. Negative 4 minus 5 is negative 9. Okay. The last one says, number 3 says g of 8. Well, let's go ahead and plug in an 8. Oh, wait a minute. This is the f function. So number 3 is a trick question for this particular one. This one, I can't do anything. There's actually nothing I could do. Why? Because I'm telling you to plug an 8 into the g function, and I have the f function. So in this particular case, you would be looking for, hopefully your teacher would give you another function that said, hey, g of x equals like 3x plus 1, right? In that case, you would then go up here and plug it into that. So let's go ahead and do that. So now I'm doing g of 8, okay, equals 3 times 8 plus 1. Remember that first line should match with 8 and 8. Thereafter, the left side is going to be your placeholder, equals 3 times 8 is 24 plus 1. So g of 8 equals 25, okay? So I hope that makes sense that I'm showing you there on that part 1. Number 4, last one. So again, this one changes because the number is outside the parentheses. So this is the case in which I need to solve, okay, or set it equal to the actual expression. So I want, in this particular case, I want 2/3 x minus 5 to yield me or produce 35. So I make an equation stating that it will, and then I solve it. So add 5 to both sides, add 5 to both sides. I get 2/3 x equals 40. Divide by 2/3 or multiply by the reciprocal of 3/2, and you'll get x equals 60. So if I want the answer to be 35, I will need to plug in a 60 into that function to get an answer of 35. So I hope that helps, but that's it, and that's the end of this video.